square root of a negative number gives you a non-real answer. That's why if we have a negative discriminant, we have no real solutions. That's why if you put it in a calculator, the square root of a negative number, it's going to say non-real answer. And in order for us to deal with that, what we use is we use this imaginary number I. The definition of I is the square root of negative 1. Oftentimes you'll see I written as a cursive I, like that. You may see some really great shirts that say, I have imaginary friends.
No, I want one.
Me too. I don't have one. So now if you see the shirt, I have imaginary friends, this is a t-shirt. That means you can laugh and you can be a math nerd with that person. I have imaginary friends. Where this all came from, Raphael Bombelli, many, many years ago, he recognized this imaginary number. He recognized that I keep getting the square root of a negative. I need something to help me continue this problem instead of just giving up, throwing in the towel, and saying I can't do it. So he came up with the imaginary number I. Can you just make up imaginary numbers? No, absolutely not. There is tons of theory and proof and work behind this. He didn't just randomly pick a number and say, hey, I want it to be I, and that's what it is. Now, at first, people thought this is really dumb, we're never going to use this. But people always also thought that 0 was not an important number. Let's just think about that for a minute. Not having 0 as a number. It's a big deal. There's a big difference between having $10 and having $10,000, all because of zeros. Think about how often we use the number 0 in real life. But whenever 0 was introduced to the general public, people thought, we don't need this. Same thing with I, the imaginary number. It was kind of hard for people to grasp, hey, we need this. This is important. But it is, and it's pretty much the most famous imaginary number that we have today. What? E and others, but that would probably be the other one that you would.
Is there any C in imaginary number?
No.
Are they all letters?
So, are you going to use I in your everyday life? No, you're not. But this is just a starting point. This is to introduce you to the number I. This is to let you know that it exists. As that paragraph says, it's used in bigger, huge topics like quantum mechanics and vibration analysis and electromagnetism. I think that was the other example. Obviously, we're not going to be doing that stuff here in Algebra 2, but you got to get the basis somewhere, and you have to start learning somewhere. And so that's what we're going to do. We're just going to introduce you to the basics of I. So how can I write the square root of negative 18 using the imaginary number? Because right now, the square root of negative 18 is not a real answer. So just like when you simplify radicals, you can break your radical into two factors. We could write the square root of negative 18 as the square root of negative 1 and the square root of 18. Now we know that the square root of negative 1 equals what? I. So this is I, square root of 18. You guys should be able to look at the square root of 18 and recognize that there's a perfect square in there. Perfect square of 9. So I'm going to simplify this further by taking out a 9 and 2. So I times 3 times the square root of 2, that's just kind of in a strange form. You would usually see that as 3I root 2. And that is your simplified form of the square root of negative 18. Cameron.
How come it's not plus or minus?
That's a good question, because you're not solving for this. If you were solving, like x equals something, that's when you use plus or minus, but this is just simplifying. Yeah, you're using I to replace the negative square root.
What are you smiling at? It's creepy.
All right, how do you write each of these? So let's start with A. The square root of negative 12. By taking I out of that square root, now you just have the square root of 12. You don't have to write that first step as the square root of negative 1, the square root of 12. You can jump right to just having I square root of 12. That's fine. Choose a perfect square within 12. It's 4. I root 3 is your simplified answer. B is the square root of negative 25. Anybody want to take a shot at what the answer to this one is? Cody?
5i.
Very good. This is just a perfect square. Simplifies to 5i. And we've got the square root of negative 7. Jordan?
I have square root of 7.
Yeah, and you can't simplify it anymore, so you just stop right there. So why would the square root of negative 64 not be equal to the negative square root of 64? Morgan? Go ahead, Morgan Catter.
Whenever you take the square root of negative 64, you won't get a real answer, but if you took negative square root of 64, you would get negative 8.
Yeah, very good. This would be 8i. This would be negative 8, like Morgan said. It all is because of where the negative sign is. It depends on the placement, whether it's inside or outside the square root. So simplifying with I is pretty simple. You just take I out of the square root because it removes the negative from the square root. The rest of the simplifying is what you've always done with square roots. Now we're going to talk about graphing. The whole section 4.8 is called complex numbers. We call it complex numbers instead of imaginary numbers because complex numbers are using both imaginary and real numbers. You can see you can write a complex number in the form a plus bi. A plus bi means you have one real part, which would be the a part, and then you have the imaginary part, which would be the bi part. The part that involves I is the imaginary part. So when you are adding a real number and an imaginary number, you have a complex number. Now, if you wouldn't have a real number there, say you would just have the bi, they call that a pure imaginary number. So think back to way back whenever we first started, probably chapter 1, when we were classifying numbers and we were talking about real numbers. Well, at that point it was kind of like, well, isn't every number a real number? Not necessarily. Because whenever you have numbers involving I, you have imaginary numbers and complex numbers. Thanks, Gabby. Just said it there. Yes, Jess.
So, what are these numbers used for? Like, why?
Anytime you have a square root of a negative.
But why?
Like I kind of said at the...
Like, how do we find?
Like I kind of said at the beginning, it's used in things that are way above us. Not like simple numbers like checking accounts and temperature outside, but things like quantum mechanics and electromagnetism that we don't use on a daily
Like,
basis.
if it's imaginary, like, you can write it, you can't have it.
Yes. And so it's a lot of theoretical stuff. Well, half the thing of wrapping your head around the fact that half the hard part is just wrapping your head around the fact that there are these imaginary numbers. Like, what? Imaginary?
Yeah.
They exist. It's
Yeah,
a
that's why
strange
it's, like,
concept.
confusing, 'cause it's like,
Because
you
like
can
they
write
exist,
them,
but they don't.
Yeah.
but you can't actually have it.
Right. You can't have
Really weird.
apples. I understand.
You can write it.
Yeah, I understand. It gets a little more complicated too because we're graphing on a complex number line that has imaginary parts and
Does every class do this, or is it just one?
well, not every class, but most of the classes are doing it. Alrighty. So we also have a complex number plane. And that's fine, you check. And it looks just like a coordinate plane, except it's for complex numbers. So we don't use the x and the y axis like we're used to. We use the horizontal as the real axis and the vertical as the imaginary axis. Okay, horizontal is real, vertical is imaginary. When we graph, we use the real part of a number to go on the horizontal, and then we use the imaginary part to go on the vertical. Now, the absolute value of a complex number. Remember, the absolute value is just the distance from 0. So if we're finding the absolute value, the distance from 0 that a point is, all we do is we take the square root of a squared plus b squared. So let's do a problem to make all of this a little more clear. Graph the number, find the absolute value. So remember, your horizontal axis is your real axis, and then your vertical axis is your imaginary axis. I just remember that because the vertical axis is straight up and down like an I for imaginary. It's simple, but it might help you remember that your imaginary axis is going straight up and down, just like the I of imaginary. So when you graph this, use the real part of your number first. The real part of A is going to be -5. So horizontally, you want to go -5 units. And then the imaginary part is going to be 3i. So we go -5 units horizontally. 3i is a positive 3 units on the imaginary axis. Now, you don't necessarily have to draw the triangle. What I want you guys to think about is, what's the distance from that point to 0? And we can find that by taking the square root of -5 squared plus 3 squared. So the distance this is from 0 would be the square root of 25 plus 9, which is the square root of 34. So that is how long your distance is from 0 to your point. So it's a little less than 6. Guys, don't make too much of it. I mean, right, you know what a distance is. You know what absolute value is. That's all you're finding right now. That has nothing imaginary to it. It's just saying how far is that point from the origin? The square root of 34. So about 6 units. All right. What is the real part of the number 6i?
0.
Right. We don't have a real part of it. This is a pure imaginary number. So that means horizontally on the real axis we don't go anywhere. We just go on the imaginary axis to 6.
Do they have a track meet today?
Shh. Okay, now if we're trying to find the absolute value, we would take the square root of 6 squared. That's the square root of 36, which is just 6. And guess what? We really didn't even need to do that. Because think about what we just found. We found the distance our point is from the origin. Well, duh. We knew that. 1, 2, 3, 4, 5, 6. No, if it would be like that, you wouldn't have to. You can just write 6, yeah. But I just wanted to show you guys, that's what we're doing. We're finding how far away is that point from the origin. Okay, let's try it. We have to graph and find the absolute value. So, remember, horizontal is your real axis, vertical is the imaginary. So, 5 is the real part of this complex number. You go to 5. And then you have negative I. So, negative 1 is the imaginary part of this complex number. So, 5, negative 1 would be where your point lies. Find the distance that is from 0. The absolute value is the distance from 0. So that would be the square root of 5 squared plus negative 1 squared.
So we don't have to simplify it?
The square root of 26? Nope. And you don't have to put it in decimal form. Just leave it as the square root of 26. Okay, you guys tell me, left, right, up, and down. How should I graph the complex number negative 3 minus 2i, Jess?
Well, over negative 3.
Okay,
Down 2.
that's right. So we graphed it. Now we're finding how far away is that point from the origin. We take the square root of negative 3 squared plus negative 2 squared. So that distance from the point to the origin is the square root of 13.
Is this all the harder than it gets?
I know. And somebody tell me directionally where I should go for C. Jordan?
1 over 25 and up.
Okay. One squared plus 4 squared. We get the square root of 17. Now remember, when we're finding those distances, distance is the absolute value, distance from 0. So we can say the absolute value would be the square root of 26. The absolute value would be the square root of 13. Absolute value would be the square root of 17. That's what we're finding when we're finding the distance from 0.